Okay, we're looking at mixed exercise 7 from the first year core textbook, and we're on proofs, and now we've got a geometric one, so we've got a quadrilateral, so we're given the 4 vertices, and we're asked to show that it's a square. Okay, so well, what makes a quadrilateral a square? It's if all 4 sides are the same length and all 4 angles are right angles. So, and obviously I haven't drawn that accurately as it would look like on the axes, but there's the 4 vertices. Okay, so what do I need to show? Well, first of all, let's think about the right angles. So obviously, if they're at right angles, they are perpendicular. So if I do, let's label up so that was 1, 1, that was 3, 2, that was 4, 0. So as I said, in terms of sort of drawing it to scale, these coordinates are not, they're not correct on my diagram. They don't need to be. If it helps you to have a relatively accurate sketch, that's absolutely fine. Okay, so gradient of AB, so change in y over change in x. Yeah, make sure I'm looking at the right values. So that is giving me a gradient of a half. I think I'll just do all 4 gradients, to be honest. I probably could justify it just from finding a couple, but I think, to be honest, it's probably just as quick. So I'm hoping CD is parallel. So for CD, change in y is, I'll do -1, -0. So I'm looking, at C and D now. So -1, -0 for change in y, and 2 -4. So that would give me -1 over -2, which is a half. So AB and CD are, I'm having a moment there, but it's all parallel. Parallel. Okay, so and then let's think about the other 2 gradients. So, not sure what I managed to do there. Okay, right, there we go. Okay, let's move this up a bit, so we've got a bit more space. Okay, so let's move you out of the way. Right, so let's do gradients of BC. So gradient of BC, so I'm looking at, let's do highlighter there. I'm looking at these 2 now. So change in y, I'm going to do, I'm going to do 2 -0 over 3 -4, so that's 2 over 1, so that's 2. And then let's just work out the gradient of AD. So now I'm just looking at these 2 for the gradient of the line between those 2. So that is going to be, I'll do 1 minus -1 over 1 -2. So that is, oh, sorry, I've made a mistake. Right, let's finish this one off. I just realised I made a mistake on BC, didn't I? So that's 2 over -1, so that's -2. Sorry, that should have been 2 over -1, so that should also be -2, which is good, because otherwise they wouldn't have been perpendicular to a half. Okay, so actually one other thing I've realised I should do is say why they're parallel. So I'm going to add to this a parallel as they have the same gradient, and then same here, so BC and AD are parallel, and then also some gradient. Okay, but that's not enough. So just because the opposite pairs of sides are parallel, that could still be, for example, a rhombus or a parallelogram. So I do also need to say that BC and so BC is the top. So let's say BC and AB are perpendicular, and then explain why. So because -1/2 times -2 is -1, and so on. Right, so Let's zoom in a little bit. No, I can't. Okay, so BC and AB are parallel, so that's covered that right angle there. So then, same reason. So are BC and CD, CD and AD, and AD and AB. Okay, so they are all parallel because they've got perpendicular gradients. Okay, but that's still not enough because just because the opposites pairs of sides are parallel and the adjacent sides are perpendicular, that could be a rectangle. So I do still need to think about the lengths. Okay, so the right. So in the end, okay. So the length of AB. So that's just using Pythagoras between these two. So the order doesn't matter. So 3 minus 1 squared plus 2 minus 1 squared. So that's just the difference between the y coordinates and the x coordinates. So that gives me the square root of 2 squared plus 1 squared. Okay, so hopefully all the others will be this root 5 as well. And if they're not, then I need to check that calculation. So BC is going to be square root of, so 4 minus 3 all squared plus 0 minus 2 all squared. So again, so those first brackets is 1 squared, second brackets is minus 2 squared. Okay, so far so good. So then I need length CD. So now I'm looking at distance between those two. So 4 minus 2 all squared plus 0 minus minus 1 all squared. So yeah, that's going to be root 4 plus 1, so root 5. And last but not least, and I mean, I think, to be honest, if 3 of them are the same length and they're all, we've shown that they're all right angles, we have proved it's a square, but to be honest, we might as well just finish it off. So the distance between A and D is going to be the square root of 2 minus 1 all squared plus minus 1 all squared. So again, root 5. So what we've shown there is all 4 sides are the same length. Therefore, A, B, C, D is a square. Okay, so we've probably done a little bit more working than we really needed to, but to be honest, it was really quicker just to whiz through and get them all. Pretty sure, yeah, so all those, yeah, and then all various gradients. Cool.